Yeah.
Yeah. Cool. Okay. So first thing we're going to talk about today is functions. So um, basically, you guys probably already know what functions are, but basically, they're really handy things that you can use to call upon if you're kind of running the same set of code multiple times, or you're testing something. You might want to write a function which encapsulates all that code, so it's all in one place. So the way you write a Python function is you first um, define the function, and then you give it a name. So for example, you can say we call a function I don't know, add Sam or something. I don't know, and we pass a parameter, which we pass two parameters. So we pass two numbers that we want to add. Okay, so we pass num1 and num2, and the next thing we do is we pass these parameters. So everything up to here basically is similar to what you do in Java, except you basically don't have any of the um, I guess defining things before that. Like in Java, you have to write like this whole string of stuff to define a function at the beginning. But here you can just write def, which defines the function, and then you put at the end you put a semicolon. That's something to remember whenever you write like an if statement or like a for loop. You always end it with like a semicolon rather than like a bracket. So that's just like something you should do. And here we can, I guess, add those numbers, right? So we can return, I guess, num1 plus num2 or something, right? So, and then we can call, I guess, add Sam and say pass two numbers like 5 and 6, right? Then we get 11, which is what it's expected. But another cool thing we can do in Python that we might be going over later. We'll go over it later. Is you can not actually define. You can actually predefine some of these values. So basically, say I called add stem of 6, right? Right now, this would throw me an error because I'm not passing two parameters, right? Num1 is still undefined, right? So if I just pass this, it's going to throw me an error saying add sam missing one required positional argument, num2, right? But what if I do this? What if I predefine num1 as like 4, right? Now, if I run this code, what actually ends up happening is, oh, what happened?
Num2 has to go before num1. Like
Oh, yeah.
the yeah.
Yeah. Sam's right. Haha, that is my bad. Okay. So now if we redefine it, sorry, that is correct. You will end up getting 6 plus 4 is 10. The reason being why what at the previous declaration didn't work. So if I go back to that, the reason why this didn't work is because I'm passing a positional argument for num1, but I'm actually not even passing an argument for num2. So you end up with the same issue you had last time. So um yeah. So, but say I didn't pass any value here. So I just called add Sam, right? But I passed like two values here. Then you'd actually still end up with 10 because Python just assumes like a lack of a positional argument in the command call or the function call is just what the values that you started with are. So this is kind of handy if you have like some predefined values of your parameters that you want to use, but you want to change them in certain function calls, you can do that. So that's why it's really handy. So now let's look at this first example in this notebook.
Wait,
So
okay.
we,
Yeah,
oh,
so so basically whenever you're defining functions, always put the ones that don't have a default value before the ones that do, first of all. And secondly, just in case you guys don't really remember from last week or if we didn't really make it clear, like compared to Java, Python actually really cares about the spacing. And so you kind of instead of using brackets to define the start and end of a function, use like a tab, which is which you can see automatically does when you press enter. But you have to make sure that everything inside the function is tabbed in order for it to count because Python really cares about that.
yeah. So the equivalent of basically like what Sam was saying with braces is just going to be the tab space that you see here. So yeah, those are both really good points and exactly what Sam said. And the other thing, like Sam was saying, make sure you define the ones that have positional arguments before the ones that don't, or that have predefined values. Okay, so now we have this random doc string which tells us what this function does. So returns the given number rounded to two decimal places, and then we replace the body with our own code. So um, basically, we're basically gonna pass like call this function, right? So we call this function round to two places. and then we pass like some number, right? Like we pass like, and then we get the value rounded to the nearest place. This is because of this built-in round function. So this is a pretty straightforward example. I think we can just skip over this. And then we look at the second example. It works as expected. I think this first part is pretty familiar to you guys. Second part, so this part, we can take a look at this, but basically all you need to know is just that the round function, if you pass like a number of digits that's gonna negative, it's gonna just move backwards basically. So it's basically gonna round like to like whatever this place is, right? It's gonna round to the first, second, third place. So it's gonna round to the hundreds, right? Hundreds place. So yeah, that's basically what you can figure out by running this code. But this is kind of not really pertinent to what our example is. But so now we see an example of what we were talking about before, right? Which is basically this example where we can predefine the value of a certain parameter and then use that parameter inside our function. So I think this is also pretty familiar with you guys. So I'm gonna kind of skip over it, just quickly run this example. So we get what we expected, right? Because 99 mod 10 is 9, so 9 candies will be left over. And then here we're going to quickly mention two different functions, which are called the time, or two different modules. The time module, which you can use the time function from. And then you can also import the sleep function from there. And these are predefined functions. So here you can define the start time and then basically print the number of seconds after the time is started. And then you can also use the sleep function to stop the program for some time. Yeah, honestly, I feel like functions aren't too complicated in Python. They're much simpler than what they are in Java. I don't know. Like, is there anything specific that you want to go over here? I think honestly, we don't need to do any of this rest of stuff. Do you want to go over recursion, Sam? Like, how can do recursive functions in Python?
Yeah, sure. Yeah.
Okay, so let's quickly go over this at the end. So everything above here is pretty self-explanatory. It's just traditional how functions and how we define them. And we can also use this syntax, remember we talked about last week, where you can use this kind of, is this substring inside this larger string, or is this word inside this larger phrase? And you can just use in to do that in Python. So it's really handy and easy to do. The rest of the stuff, so here this is going into slicing a bit, but we have a separate document that's more or easier to understand than this example. So we'll come back to this later. But moving on to the end, where we quickly talk about recursion. So if you guys have taken CSA, I think it's called. So basically APCS, you guys have learned about how recursion works, which is basically a self-calling function until some base condition is satisfied. So you basically are, so the way you define these functions, the intuition behind these functions is still the same. The only difference is like how you code it, obviously, or the implementation. So in this sense, in this question, we're trying to write a function that counts the number of occurrences of a specific text. So we basically are defining this text, right? Which is there a dog here? I think I saw a dog. A dog would be great. And the subtext is going to be dog. So rerunning this with recursion, we find that there's 3 occurrences of the dog, which is correct. And basically all we're doing with this function is we're using this inbuilt find function, function to basically find the subtext inside the text. And this will basically find like the first occurrence of it. So you basically go through and just find the occurrences of the text. And then once you end up at a position that's equal to -1, which basically means that it's not able to find any more occurrences, then you'll be done. Because what you're doing at the bottom is you're basically cutting out the strings or like the indices that you've already checked. So once you like find the first occurrence of dog, you basically cut out everything before here, right? Because you already counted it, and then you just be left with what's after it. And then you keep running this function until you end up with a position equal to -1, or you're not able to find this subtext inside the text. And this is a repeat of that. Okay, cool. So we finished this. Cool. So that was pretty quick. So we quickly went over functions there. I don't think there's anything really complicated there. Does anyone have any quick questions about functions? Do you guys feel comfortable with functions, or do you want to do some more practice with them? What do you guys think? We're gonna have some practice problems at the end, obviously, which go over like a lot of the concepts we went over together in like one problem. But I have a separate notebook that just goes over functions with booleans, so like returning, doing comparisons and functions, things like that. But I think you guys could probably review that on your own. So I'll probably just upload this separately, like at the end, and you guys can take a look at it on your own time. But now let's move on to slicing. So let me reshare my screen really quickly. So we move on to, so let's quickly actually review for loops from last week. So if you guys remember quickly that you can use this range function to define the value of I through the iterations. So basically I will range from 0 to 2. So it'll go from 0, 1, and 2. So this will run 3 times and print boink, 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 doink 3 times. You can also do some other things where you can print out like a star, and then you can multiply it by the number of iterations of I, and you'll end up with something like this. Or you'll end up with like an output that's like blank, then it'll be like 1 star, then 2 stars, and 3 stars, and 4 stars. So you end up, that's basically the output of this. And now we can do this challenge problem. So write a program that outputs this using a for loop. It's kind of hard, so you might have to do a lot of testing, but please do it. Okay, so we're gonna try to output this with some code. So basically this is just 1 star in the first line, 3 stars in the second line, 5 stars in the third line, and 7 stars, I think. 7 stars on the fourth line. So let's quickly make a notebook for this. And see what you guys can do. So we'll call this the star problem. So if you guys all have Jupyter Notebook working, so go in and just make a notebook and try doing this really quickly. So you're going to try to print this out by using a for loop. So making this figure right here with the for loop. So if everyone can just go do that right now, I'll give you guys 3 minutes to do that. So at 3:40, I'll come back and then I'll call on someone, and then you guys can just tell me what to type, and we'll see if your solution's correct. How do you guys feel about it? This question. You guys feel pretty good?
Giving it our best shot.
Okay. Sounds good. If you have a solution, raise your hand so I can know how many people are have a solution. So like, raise your hand. No one yet? Do you guys need more time? Okay, one person. Anyone else? So Victor, are you done? Arul, maybe. Shriram, anyone? Anyone else done? Okay, cool. We're getting more people. So if you guys want a hint, just think of this question right here. So we were able to, you guys can still see my screen, right? You guys see my screen? So if you think about this question, right, we were able to print out these 5 stars, but we did it using this for loop where we printed out like a star and then times I. But now, if you guys notice, we have like a spacing problem, right? Like we have like a certain amount of space that we're giving to each line. So think about how that factors into your multiplication. All right, okay. Let's call on Abhinaya. So Abhinaya, what was your solution?
There's probably a better way to do this, but I said for I in range 4, and then after the colon and the indent, I said print space times, and then in parentheses 4 minus I plus, and then
Hold up. So you said print what?
Space times, or I could just put it in the chat if you want.
Yeah, sure.
Sanjay, I'm pretty sure she meant like a space in like quotes.
Yeah.
Plus what? Or you can just say, actually, I think it's fine.
Okay, a space times, and then 4 minus I in parentheses.
No. She said the space times 4 minus I.
Oh, space times 4 minus I. Okay.
All right, and then plus the asterisk in quotes times I times 2 plus 1.
Plus times I plus like this, or?
Yeah, like that. So I times 2 plus 1.
2I plus 1, basically.
Yeah.
Okay. Yeah, I think this is like a fine way to do it. Like, I think it's pretty okay. Yeah, I don't think there's anything wrong with this. This is probably a good way to do it. Okay, anyone else have a different solution that they would like to use, like to say? Everyone else had like the same solution?
Yeah.
Okay, cool. Okay, cool. That's good. So going back now, let's quickly take a look at slicing again. So I think we basically mentioned, like, we basically briefly talked about how to define like a list, right? So this is like an example of like a list. And we can add elements to a list, and we'll talk about all the different functions or methods associated with lists later. But for now, just focus on like how we can grab, I guess, items from a list. So, for example, if we want to grab the months from April to July, we can use this traditional indexing that we see in Java, right? We can also do some more interesting kind of indexing, or what's called slicing, with this. So say we want to grab, for example, every other month beginning with the index 1 or February and going to the end of the list, right? So what we can do is we can say we want to grab month 1 to the end. So by leaving this blank, we're saying to the end, and then we can say the skip or like the increment is 2. So this is similar to like how we define like the range function, if you guys remember. So the same kind of parameters are in the range function, where we have the start, stop, and like the increment. So, oh yeah, exactly what Helen was talking about later on. So we have the start, stop, step kind of notation for slicing. And this is all 1D slicing. So when I say 1D, I mean the list is like a 1 dimension, right? We only have like 1 dimension of the list because it's kind of just the whole row. But once we get into complex like lists and what's called numpy arrays, you'll start to see like that slicing becomes very important and like becomes very intuitive. But for now, we're just gonna go with some basic stuff, and yeah, so we're gonna focus on just 1D. So this one right here is all the first 9 months, incrementing by 3. This is all the months starting with the 4th. And now let's actually look at some kind of new things. These are things you guys probably haven't seen before. So we can use negative indexing in Python, which is not available in a lot of other programming languages. So here we can say, for example, if you want to get the entire list except the last index, we can do this, right? It's like a traditional / long way to do it, but it actually can be done faster because this is actually going to take like longer to type and stuff. So you can use slice notation to make the parameters negative. So instead of writing this to say we want to get all the elements except the last index, we can just shorten it to say this, which basically means that we're just getting all the indexes except the last one. And if you only want to get the last 6 elements, we can do this right here, where we put like -6 and a colon all the way to the end, which basically means that we're trying to grab. So we have the way to think about this notation right here, like when we have negatives, is you're basically trying to grab all the elements from the front, from the back to 6 before the back, which basically means we only want to grab the last 6 elements. Because you can think of this first index as where you start, right? And if you define it as -6, you're basically saying I want to start 6 from the back. So you're basically starting 6 from the back and moving to the end. And if you want to get everything except the last 4 elements, then what we can do is, using the same idea, we can say, look, so we want to end on a position that's 4 less than the last element. So instead of doing like length -4, we can just say semicolon -4, which means that we start at the beginning. Remember, if you don't specify like a range or number for the each of the parameters, it defaults to the lowest for the starting, the highest value in the list, or the highest index in the list for the ending, and the increment's going to be predefined as 1. So if you want to get everything into the last 4 elements, we use the same kind of idea. And then here we can use a negative step parameter in a for loop. So basically, we talked about 2 different types of for loops, 2 different ways of using for loops, right? The first is by using like a for loop to basically increment some variable, right? So like for I in range 10, we increment I from 0 to 9. But if we say like for I in numbers and then use this slicing notation to basically say we want to get everything in the list, but use a negative step size, what do you guys think this will output? So if I just copy this code over to this notebook here, what do you guys think this will output? So intuitively, what do you guys think? If we're basically saying we want to go from start to finish, but we want to use a negative step parameter, what do you think that, guys? What do you think this will output?
The list reversed.
Yeah, basically. Oh, yes. This is where the indentation comes up. So I accidentally put like an indent right here, right? But Python is, like Sam was saying, it's very white space specific. So it's gonna throw an error if you don't have this like space right here. But basically, like what's I think our rule said, it's 4, 3, 2, 1. We basically reverse the list. And yeah. So also, like Helen's saying here, this applies to strings also. So slicing applies to like lists, but also strings. It also applies to NumPy arrays or NumPy ND arrays that we're going to talk about more later. But if I'm just thinking about the basic data structures for Python, that are pre-built into Python, the 2 main ones are lists and strings. So if we have this text right here, which is like Python is hella cool, then we can use the same sort of indexing we've seen or slicing that we've seen to kind of print out different sub characters or characters of the entire string. Okay, cool. Okay, so here Helen goes over some basic list comprehension that we're going to talk about in a second. So this is kind of all I wanted to go over slicing. But do you guys feel good about slicing right now? Like, do you guys feel like you understand the different, I guess, ways to perform slicing, like both within the, so yeah, like, do you guys understand like that you can use both negative parameters but also positive parameters, and that it's obviously more advantageous to use negative parameters when you have to like grab something from like the end of the list or something. So does that make sense to everyone? Any questions about that? No questions? All right. Okay, let's move on finally to lists and tuples. So I'm sorry, lists, tuples, sets, and dictionaries. We're gonna go over all of those today. Okay. So we're going back to the same notebook that we used last week. I think someone had a question though. Let me check what the question was. You can also return a copy of a list by putting list name. Yeah, you can. Yeah, I don't know what else to say. Then yeah, you can do that. Sure. But you can also just define like a temporary list that's equal to that. But I don't know. Either way, it works, to be honest. But anyway, so we went over all of this last week, right? Sorry, this notebook's empty for these sections because I made a copy of this and added stuff to it. But I will copy back the solutions into one notebook, so it's all in one place before I upload it again. But anyway, so let us now work with some more complex data types that are inbuilt into Python and are used to hold more data than a variable can. So there's kind of 4 collection data types in the Python programming language. So the first is a list, which is a collection that is ordered and changeable, and it allows duplicate members. A tuple is a list, as a collection, which is ordered and unchangeable and allows duplicate members. So basically, a tuple is equivalent to a list, except for the fact that a tuple is immutable, which means that it's unchangeable once you predefine it. So think of like a tuple as like a the difference between like defining the size of like an array and like a list. When you define like an array in Java, right, you gotta have to specify like, I guess, like the size of the array. But with the list in Java, you don't have to do that. So think of like the same difference as tuple and list with its elements. So tuples elements can't be changed once they're defined, while lists you can add to them or remove from them. Sets are collections which are unordered and unindexed, and there are no duplicate members. And a dictionary is a collection which is unordered, changeable, and indexed, and it has no duplicate members. So I guess if you guys want to make parallels between all of these and their Java equivalents, a list is basically the same thing as a list in Java. A tuple is quite similar to an array in Java. A set is like a set in Java, and like a dictionary is quite similar to a map in Java. So yeah. So first we're going to be looking at lists and tuples, and then we're going to go over dictionaries and sets. So throughout this section, just keep in mind that Python is 0 indexed, and also additionally pay attention to the types of braces being used during instantiation of each data structure. So first, when you define a list, the first thing you guys can use to like identify that it's a list is that it has these brackets. So I don't know what these brackets are called, but they're like, wait, what? I don't know what these are called. These are called like, wait, Sam or anyone else, do you know what these like are called? Like, what are these brackets called?
I think they're either called hard brackets or like square brackets.
Yeah, harder square brackets. Yeah, like Victor's saying. So when you see like a data structure that's defined with these harder square brackets, you know it's going to be a list. And you don't have to specify like a data type or anything. Python, like if you go back to last week, we went over the fact that Python is able to kind of interpret what the data structure of this is going to be, which is why when you specify like the type of the list, it's going to know it's a list. And you can print out the list. You can also create a list using the range function. So basically, you'd put all the elements from 0 to 10, obviously excluding 10. And then you can also perform slicing like we went over. So you can get like the third element of the list using this method. You can get the first two elements using this slicing notation. You can get the last three elements by setting the start to 2, the index 2. You can also get the length or the sum of a list. And these functions are pretty ubiquitous around most data structures. So you can use these generally with a lot of the data structures you have here. So now we're going to go over a few kind of functions that are, I guess, analogous to what you'd see in Java. So if you guys remember, in Java, you could append to a list, and so you just use .append for that. You can also pop the last element off the stack, or like, I'm sorry, not the stack, but off the list, which basically means you're just removing the last element that's added. And you can also concatenate two lists by using this plus function. So you can basically just like add a list to another in like a print statement, for example, and print it out, and it would just append these elements to the end. So this is quite handy. And you can also like concatenate lists like intuitively. Like you can add like int list 1 and int list and int list 2. You can add them together. You can replicate the list by multiplying it. So this is similar to what we saw with strings in a few minutes ago with the slicing section. We saw that you could like multiply like strings with like an integer replication factor to get a larger string in this case, a larger list. You can also insert items at specific indexes by using the insert function. So you can, for example, insert a 4 at index 2. And you can also sort them, like you can sort array lists. And in Java, you have to use like the collections, I guess, class, or that's what it's called, collections class, to sort it. And in this case, you can just do sort and then use the reverse equals true to sort it in descending, or just not specify anything to keep the reverse equals false. And then you could also, at the end, specify whether you want it to be reversed or not based on what type of list you're trying to sort. So all these functions right here are pretty standard and intuitive. I don't think there's anything here that's complex. Here, we are just going a little bit more into lists, but this time using a list of strings. So I think this stuff is all pretty easy, right? Nothing too complex here. It's just all the same functions. But here, we're looking at something a little bit more interesting. So we can merge all the elements into all elements of a list into a string by basically using this join function, which basically what it allows you to do is it takes each element and adds and joins it to the separator between each of them. So in essence, we're making the separator this like space, right? So in essence, what you're doing is you're basically just putting a space between all the elements by joining it. And something else that's pretty cool is you can use this another function called map. So you can like do like a dot join, and then in the join function you can like map. And what this basically allows you to do is convert data types inside this join function. So for example, like say you had like a string, or like you had like a list of floats, right? And you want to convert all the floats to strings and then join them with like a separator. You could map the string and then map like each of those items, and then you could use this like Pythonic way of a for loop, which is like in a single line. You could say like for you can do this basically, and this is equivalent to what you did up here. And you're basically just mapping the string data type to each item, and then you're saying for each of the items in the my list. So yeah, that's pretty cool. And you can also use the remove function. Like I think we mentioned it up here too. I know we didn't. Okay, you can use the remove function in list to remove an element. And yeah. All right. Okay, so we're gonna come back to dictionaries. We're gonna go on to tuples now. Just first of all, before I move on, actually, does anyone have any questions about lists? Any questions about them? No questions? All right. Okay, let's move on then to Tuples. So tuples are going to be instantiated with these curly braces, I think. This is what these called, curly braces. Or no, sorry, not curly braces. What am I saying? Open parentheses and close parentheses. Sorry. So you can define like tuples with these. So we're going to first define a tuple with the state's code, and then the name of the state, and then the capital of the state. So for California, that'd be CA, California, Sacramento. Over Texas, that'd be TX, Texas, and Austin. And then we can just first of all print this tuple, this Michigan tuple, and then we can use the same indexing principles. So if we index, for example, this first element, we get Michigan and Lansing, because we're getting from the first element to the second, element at the first index to the element at the second index. So we're getting Michigan and Lansing. And then we can create a list of tuples by just by instantiating states equal to that. So that's something important to note. Usually this is done very often. You have a list of tuples put together. And this is usually common when you work with either large data where you have to like compress it easily, and you want to have fast access to it, because you can access tuples very quickly. So they're like, it's helpful to create lists of tuples if you're working with large amounts of data. And then you can, and now we're gonna get into some of this 2D kind of, we're working with kind of 2D ideas now. So we have so each of these tuples themselves consist of elements, right? But then we're putting together all the tuples together to make a list of those tuples. So we can access, for example, specific elements of the specific tuple. So for example, this MI tuple is consisting of 3 elements. The CA tuple is 3 elements. The Texas tuple is 3 elements. So if we call states of 2, we get the Texas tuple, right? And we get Texas, Texas, Austin, TX, Texas, Austin. And then if we print out the first, this is like I think Abinaya was saying, this is equivalent to this, where you basically have, you're basically just saying that you want to get all the elements at that index. You want to get all the elements in the Texas tuple, but you can just like not specify this and get the same thing, and you still get the same output. Here we're getting just the last 2 elements of the Texas tuple, so just Texas and Austin. And lastly, we're using now something that's very interesting. So we're basically using this thing called a lambda function. So basically what we're saying is we want to sort each of these, we want to sort this list of states by their capital city. So this is a very, very common thing you'll see in Python. It's like pretty common, where if you have like this 2D listing or something, or like something that's greater than 1 dimension, where it's not just a list of elements, where it's like a list of a data structure, like list of list or a list of tuples, you'll see something like this, where you sort by a specific value inside the tuple. So in this case, we define the key, which is basically what you're sorting by, to be the state and the second index of that, which would be the capital city, right? So 0, 1, 2, second, this is the capital city. And then we print out the states by their sorted positions. So this is how lambda functions work. And the general syntax for lambda functions is you'll have like lambda x, and then you'll specify what you want to do with that. And when you say lambda x, it's equivalent of saying like for each x in whatever you're sorting by, or like whatever you're using the lambda function for. So in this case, when you say lambda state, you're basically saying for each of the state tuples in the states, we want to take the second element of that. And like I mentioned earlier, you might notice that there are no like functions or methods to add or remove elements or anything like that. That's because, like I said earlier, tuples are immutable, which means that you can't add or remove from them. And then I have some random stuff here. Okay, I don't know why I put this exercise here, but use a for loop to add all the numbers from 0 to 1000 and print the sum. So this is like a pretty simple exercise. So I guess why don't we do this together? So what do you guys think we do here? I don't know, anyone? Just want to say it out loud. Oh yeah, also that's a good point, Victor. Yeah, like what I was saying earlier is similar to like what we saw in CSA, which is like where if you set one value equal to another, it's still gonna have the same reference. But so if you want to create a true copy, you can use what Abinaya is saying, which is like um getting basically grabbing all the elements with the semicolon. Um, yeah, that's probably like a better way to do it. Yeah. Because otherwise you'll run into issues where like if you are like I guess exchanging values between two lists, you'll end up with an issue there. So yeah, thanks for mentioning that, Victor. Okay, does anyone want to do this question, by the way? Just quickly, just want to tell me what I should type.
For I in range 1000,
Mm-hmm.
and then the next line, total sum equals I, and I print it.
Yeah. Oops, can't type. Yeah, so this is intuitively correct. Because you can like do the math and it's right. So I think that's it. Okay, now I want to quickly go back to Helen's like list comprehension stuff really quickly before we move on to dictionaries and sets. So basically, what list comprehension is it's basically a faster way of using for loops, but without having to use like this like whole space to write like a single for loop to do a simple task. So, for example, say we had this like list of names, right? So Bob, Joey, Billy, Tom, John, and Bilford, and then we want to basically add all the people who have the first name B to this new names list, right? So what we're gonna do here is to loop. So the naive solution here with like if any programming language is just to loop through all the names, then check for each name if the first index is B, and if it is, then you should append the name. But there's like a much faster way to do this in Python. And basically what that is you can use this thing called list comprehension, which is basically like a shortened, you can think of it as like a shortened for loop. So basically like the way you would rewrite this declaration of new names is saying n for n in names if n0 equal b. So in essence, you can think of this as like this is a single for loop, and then you have this if statement, and then if this if statement is true, then n is going to be added to new names. So this technique, like I was saying, is called list comprehension. So you can use this for like a variety of things. So in general, like the format is you specify what the like output or what you want to append or add to this new declaration. So in this case, it'd be n dot upper, which basically is all the uppercase names that start with the letter B. And then you write out the conditions. So for n in names, if n0 equals b. So that's the traditional, like, I guess, format of list comprehension. So I think this is like a pretty. This is not a complex concept. So this one is gonna obviously make everything lowercase, right? Just n dot lower for n in names. So now let's do this quick um, challenge. So using the provided list and list comprehension. So list comprehension is always going to be one line of code. Generate a new list that contains reversed versions of only the words that are longer that are longer than 5 letters. So this one is like a challenge question. So I'll give you guys like 4 minutes to do it, or 3 minutes, because we're running a little bit low on time. Oh, by the way, Just in case some of you guys think there's like an inbuilt string reverser in Python, there actually is not. So there is no like string.reverse function. So think of like the smart slicing we did earlier and how we can apply that to this question. It's just a heads up if you guys are thinking that. Okay, so does anyone have a solution for this?
Yeah, I think I got it.
Who's this?
EFOM.
Fine. Okay, cool. What do you think it is? Give it a shot.
Like new words equals to hard bracket.
Let's print it out so we can just do a print statement, or we can. I don't know. Let's do this. Let's print it out. So we actually first need to define words. Before I do that. So let's go. But yeah, go ahead. I'm listening.
New words equals to like before the print line. Oh
no,
yeah,
no,
yeah.
You can put it out here.
Like n, and then hard bracket colon -1, like retrieving the string reversed.
We need to. But
yeah.
So
and like n before the hard bracket. Like
so
the
yeah,
n
in the hard
outside.
bracket.
No, like n outside the hard bracket, you retrieve
outside
it.
Outside the hard bracket. What do you want me to do?
Like before it, like print.
Before the hard bracket. Okay.
N, yeah. N.
N.
Yeah, just like, and then colon -1 inside the hard bracket.
Okay, I know what you're saying. You're saying this, right?
Yeah. And then for n in words, if length n is greater than equal 5, greater than 5.
Is this what you said?
Yeah, it's greater than 5. Yeah.
Yeah. Okay, that's correct. Honestly, it's kind of like I know what you're saying, but like I don't want to type it if that's not what you're saying. If that makes sense, because I don't want to like misconstrue. But I know you're right. That's right. That's right. So yeah, we get the right answers. Good job. So actually, like I think there might be a better way to like ask you guys to do it. Maybe you guys should just share your screen or something. I don't know. But anyway, yeah, correct. This is correct. This is a smart way to do it. We're using both slicing along with this list comprehension that we learned. So 2 and 1. Overall, good stuff on this question. Okay. So lastly, I'm gonna quickly just like speed through sets and dictionaries. Just speed through them for like 5 minutes. And then we'll come back and review them to the beginning of tomorrow in case if you guys have like any questions with them. All right, quickly, let's go through this. So we're using a for loop with a list, and we're replacing all the words that have is with at. So for example, this is going to be replaced with that. Is going to be replaced with at. A is not going to be replaced, and list is going to be replaced with lat. And now we're going to print out the length of each word for each of the words. So this is list comprehension. And now we're going to move on to sorting with tuples, right? So we sorted by the capital. So first we grabbed the second state for each of the states, and we sorted by that. So in this scenario, we're not sorting the whole tuple, rather we're just sorting the capitals by alphabetical order. And then here we're going to see how we can use a dictionary. So going back up here, dictionaries are defined with these curly braces. And basically dictionaries, the way you add elements to them is basically like how you define elements of like an array. So in this scenario, what you basically do is you set like the element equal to the element in these square brackets, and then you set that equal to the value. So if you guys know maps, anything about maps, you know there's like a key value pair, right? In a map. This is equal to like the element value pair. That's the definition in Python. So they're basically synonymous with each other. So we have this, we define the element or the key as MI, and then the value is Michigan, the key is MN, and the value is Minnesota, and then we keep going down. And now we see a list of functions or methods we can use with dictionaries. So first we can grab all the keys. So the keys are just going to be all the like things inside the square brackets. So all the elements. So we're going to get all the 2-letter codes for all the states. And then if we grab the values, we get all the values. And then we can get the length of the entire dictionary, which is basically just counting the number of key value pairs we have. And also remember that dictionary can have duplicates, so that's a good thing. We can also grab certain elements, and if we grab an element, we grab it by the index or the element / key, not the value. And we can also check if we have certain like keys or values inside the dictionary. And then here we can use something cool called the zip function. So basically what we have here is we have these different keys and values. And if we want to make a dictionary, instead of having to like do this like tedious definition, we can use this zip function to zip each of the keys to the corresponding value. So this is like a very handy way to do it if you have like 2 lists, for example. So you can zip the keys and values together, and then you can obviously sort it. And remember, if you sort it, it's going to sort it by the key. So here we're sorting by the key of the dictionary, and then here we're sorting by the values. And these are using the same principles we saw earlier, where, for example, in like a tuple, we used these lambda functions, but instead we can use this item getter Python library, which can do it for us. Instead of having us like write a lambda function, we can just use the item getter library to grab the specific key we want to sort by, or sorry, to sort by the key rather than the value. And yeah, okay. Now moving quickly on to for loops to dictionaries. This is quite important. So we're going to use list comprehension but with dictionaries now. So what we're basically going to say for the items in fruit, we want to get each of the Ks for the K value pair. So items is basically saying like for each of the key value pair. So a key value pair is going to be an item. And we're basically grabbing all the Ks or the items. I'm sorry, the keys. We grab all the keys. So we grab apples, oranges, bananas, cherries, and then we print those out. And that's that. Okay, so I sped through that really quickly, and now let's quickly just go over sets before we're done. So sets only stores unique values without any order, and they're unindexed and therefore can be used to remove duplicate entries or perform comparisons between lists. And in Python, sets are written with these curly brackets. So you can like define a set as like this, and then you can also say something like to see if it's defined as a set. Yeah. And then in order to add elements to the set, you can use the add method, and to add multiple items, use the update method. So, for example, if you want to add all these different names, we can use the update. But if you just want to add a single element, we can just use add. And we can use the remove function or remove method like we did with lists. The difference between the remove method and the discard method is that discard does not raise error when the item that you want to remove is not in the list, but remove does. So, for example, if we try to remove some other element like, I don't know, like 1, it's going to throw an error. But if we try to discard 1 from here, it's just not going to do anything. It's not going to raise an error. And then you could obviously, the main purpose of sets, like in generally when you only use sets in like machine learning / data analysis if you're like merging 2 lists using like a set to figure out what elements are overlapping or there's like intersection between them is what you basically only use sets for. I don't think I've ever used a set for anything else. So you'll basically, for example, you can use a union function to add all the elements of these 2 sets together. You can also use the intersection function. And you could also, this is probably the most important thing, you can convert lists into sets by just using the set function and converting that list into a set. Okay, if you guys want to do this question I wrote a long time ago, you guys can just do this and then do this review question, and then we'll review those at the beginning of class tomorrow. Sorry, not tomorrow, next week on Tuesday. So if you're still feeling a little bit shaky, go to codingbath.com/python and practice list 2. So optional, right click optional. So that's like an optional assignment for everybody if you guys want to do that. And that's about it. So that's all for today. Sorry for the rush at the end. I took a little bit longer at the beginning than I wanted to. But we will go over and review dictionaries and sets for the beginning of class. So if you guys have any issues with those specifically, after you guys take a look at the notebook this week, just let us know at the beginning of class next time, or just at us on the Discord. Both of those are perfectly good ways to get in contact with Samurai. Do we have any final questions before we're done for today?